This video is going to cover the definition of equivalent expressions. So let's go ahead and get started. Equivalent expressions are expressions that have the same value. And I want to start this lesson by talking about scales. Remember, scales show which side is heavier. Now, if my scale is balanced, or as this scale says, equal, that means there's the same amount of weight on both sides. And you'll notice on each side of the scale on this picture I have 2 cats and 3 dogs. Now they're arranged in a different order, but we all know that it doesn't matter what order I set these animals on the scale. Okay, if there's the same number of cats and the same number of dogs on both sides, that they are going to be the same. We could say that they are equivalent. Now let's go ahead and add some math to that. So 2 cats can be represented by 2C plus 3D is going to represent my 3 dogs. So I can this scale still shows this equivalency because they're equal, because both sides represent 2 cats combined with 3 dogs. Okay, and we can see that the same goes for expressions. Notice that this expression is 2C plus 3D, and this expression says 3D plus 2C. Now, if I asked you this, if they were the same, I'd hope that you'd say yes. I'd hope you'd say yeah, because the 2C represents 2 cats on both sides, and the 3D represents 3 dogs on both sides. And if there's the same number of cats and the same number of dogs, that scale would be equal. Now, if we were to look at this expression and compare the two, okay, notice that it says that they are equal. Okay, that equal sign is saying they're still balanced. But you might say, I'm not sure about that because on the left, it's a minus, and on the right, it's a plus. So how is it that they're the same? Remember that idea of terms. Remember when we were combining our like terms, we looked at 4b and then we snipped it into 2 pieces. If I look at the left-hand side, I can see that it splits into 4b and negative 3k. If I go to the right-hand side and I do that same thing, negative 3k snip, I can see that it splits into negative 3k and positive 4b. Now let's compare both sides. Both sides have positive 4b, and both sides have negative 3k. And negative 3k. So you can see it doesn't matter the order that I write these terms in or these variables in, as long as they keep the correct positive or negative sign. So let's look at a different example. This is your term. What is an equivalent expression to negative 3e plus 2b? Take a second, pause, think about that for a second. What do you think an equivalent expression, what would balance out the scale on the other side? What would be representing the same expression? All right, let's talk about it. So negative 3e, snip. So I am breaking it down into 2 parts, negative 3e and positive 2b. How else could I write that? That would represent the same thing. Well, I just need a positive 2. I'm going to maybe reorder this. I'm going to take the positive 2b first, and I'm going to drop the plus sign because I don't need a plus sign to say that something's positive if it comes in front, and a negative 3e. This would be an equivalent expression. Well, what happens if I have 3 terms? Positive 2y, snip. Positive x, snip. Negative 4y. I can make an equivalent expression by rearranging these terms. So let's say we start with the middle term. X, let's do alphabetical. X, and then a positive 2y, so I'm going to write plus 2, and a negative 4z. Notice if something is positive, I write a plus sign. Now you might say, I would have written in a different order. Maybe I want to start at the end and go forwards. Well, that's okay. As long as the negative 4 stays with the z, the positive x stays with the x, and the positive 2y stays positive. Now there's a couple other ways to write this, but we just want to make sure that the negative 4 stays with the z, the x stays by itself, and the positive stays with a 2. Equivalent expressions that have the same value. Also remember that I can distribute. That would also make an equivalent expression. So if I were to multiply 2 times 3, that would give me 6x. And multiply 2 times -5, that would give me -10. Now these would be equivalent expressions because they represent the same thing. Essentially they represent the same number of constants and the same number of x's. Okay, well let's look at this example. What could be an equivalent expression? Well, I could just rearrange the order. -2x, +5x, and +6. Notice a snip, snip, snip. +5x, +5x, +6, +6, -2x, -2x. But how else could I write that expression? Okay, well remember that we could combine like terms. These two terms have an x on them. So if I were to combine them, -2 and +5 give me a grand total of 3 x's plus 6. So this would also be an example of an equivalent term. Okay, so what expression would be equivalent to 4k minus 3 plus 2k? Now there's a bunch of different answers. You could just rearrange the order. You could combine like terms. Take a second, pause the video. When you're ready, press play. All right, I could just reorder them. So maybe I would want to go from last to beginning. So first I need to know what terms I have. 4k, -3, and +2k. So let's just reorder them last to beginning. 2k minus 3 plus 4k. Or I could start with the middle term. -3 plus 4k plus 2k. And I could rearrange these in any order. Or it is also equivalent to combine like terms. So if I combine like terms, this has a k and this has a k. And I would want to combine together 4k and 2k, which is going to give me a grand total of 6k's. And nothing can be combined with that -3, so I leave it separate. And that would be my final answer. All right. Now this is a little bit of a thinker. So if I was to use that expression that we just talked about, okay, Jamin claims that the answer is -3 plus 6k. Okay. Kevin disagrees and claims that the answer is 6k minus 3. Who is correct? Take a second and answer that question. Who do you think is correct? When you're ready for the answer, press play. All right, here's the answer. They're both correct. Okay, remember, if I simplify my expression, which is what Jamin did and what Kevin did, we went from having 3 different things to having 2 and 2. You'll notice that when I wrote my answer, I wrote 6k minus 3. My answer agreed with Kevin, but would it be okay to write it the way Jamin did? The answer is yes. If I was to snip my terms into 2 pieces, 6k is positive. That matches the positive 6k that Jamin had. And then I have a -3, and Jamin also has a -3. So these 2 expressions would be equivalent. Also meaning if I were to set them onto a scale, they would balance each other out.